So, welcome everybody. My name is Michael. I work with AWS based in Munich as a solutions architect. I'm mostly working with our customers across Germany on things like Hadoop, other big data technologies, well, pretty much everything, I would say. And today I want to talk a bit about customizing Amazon Elastic MapReduce, or EMR, I'm going to call it from now on. I'm going to do a very brief overview about EMR, because it's important for some of the points later on. I'll try to restrict that a little bit. Then I'm going to talk about like sizing configuration, how you can influence the actual software configuration on the cluster that you launch. And I'm going to talk about software versioning and bootstrapping in particular. So my network is my trusty iPhones. I'm not sure how well the demo will work, but I guess we'll just give it a try later on. If you have any questions, ask them right away or at the end. You can also email me at the end if you have anything you want to talk about. All right. That's my marketing slide. EMR is supposed to be like the easiest way to run Hadoop in the cloud. I think that's the case. I think it works fine. We started it like almost 4 years ago now. Basically, what EMR is Hadoop as a managed service, or actually many Hadoop clusters as managed services. Basically, it means you can launch clusters. The framework or the service itself will keep them alive, will replace nodes that fail, and so on. It helps a bit with tuning in the cloud. So EMR nodes run on Amazon EC2, so they're virtual servers. And depending on how you set up your cluster, we're going to tune it in advance. We also support a couple of different pricing options, so things like EC2 and spot instances, if you're familiar with those, that help to resolve or reduce the cost of running an EMR cluster. There's a couple of extensions that we added to Hadoop proper. I'm going to talk about those later in a bit, but mostly things like accessing some of the data stores that we have, things like DynamoDB, for example, and other services. And overall, we try to keep it as open as possible and grow like an ecosystem around it. So there's many BI tools that you can connect to EMR, like different IDEs that you can use to launch clusters that actually help you debug your code and so on. All right. So what EMR pretty much does is it covers the whole life cycle of the cluster, from creating it up to the very end, when you actually free up the resources and basically give back your virtual machines. One way to do it is to just create a new Hadoop cluster, basically wait until the machines have been provisioned, then just submit and run Hadoop jobs, as many as you like basically, for as long as you like, using Hadoop commands, using things like pig shell or hive shell or whatever. And then at some point, eventually, if you want to get rid of it again, you can terminate the cluster again. And EMR basically covers the life cycle. So it takes care of provisioning the resources, it takes care of keeping those nodes alive while you have things going on. It will take care of monitoring and so on, and at the end it will help you clean up the mess and hand back to virtual machines. You might wonder why it says job flow here. That's one peculiarity of EMR, and one of the original ideas behind it was that you basically see Hadoop clusters as throwaway resources. So the idea is you start a flow of jobs, basically a pipeline, feed them with some data, the jobs will run sequentially, will pass data from one job to the next, and at the end it will automatically shut down the cluster and store the results someplace else. So that's why we call it job flow. It doesn't really matter if both execution mechanisms work, but it's just a peculiarity in the naming. Okay, so how do you actually start a cluster? A couple different ways. You can use the management console, where you can put in things like names and select the version, pick the right size, and so on. You can also use the command line tool. That's what most of our customers use, I think. So that's like one example of starting a cluster. That's what I'm running the demo on. A Of course, you can also use the API, various SDKs, and so on. And there are a couple of third-party tools that I mentioned that allow you to run a cluster. All right. So the general idea is you have your input data somewhere. Those are a couple of the options we support. Obviously, you can also have like relational databases using Scoop and so on, or upload data to HDFS directly. But the nice thing about this is that then you can basically take your MapReduce code or your Hive or Quick codes and pass them on to the EMR service and ask it to give you a cluster. Then it will basically go ahead, create like the name node or the master node, it's a more appropriate term these days, and then create a number of resources for the cluster. So those run obviously job trackers. They can access the data from the input location. They have their own HDFS where they can execute jobs, store temporary files, and so on. Then you have a couple of different options. You can just let it run, or you can just connect to it with various BI tools, or just SSH into the node and run Beeline or whatever. Or you can open a JDBC connection, things like that. Or you can just have like a job or a group of jobs run and then save the output somewhere. Typically a simple storage service or DynamoDB, but it could be anything in fact. And the nice thing about this kind of architecture, if you have like separate sources for your input data and a separate sink, so to speak, for your output data, that you can just terminate your cluster once you're done and save on the cost, because at this point you only pay for the storage rather than compute resources. The other benefit of using this pattern, so that's the basic idea behind the job flows, right? Put your input data somewhere, run a pipeline of jobs. At the very end, put the data somewhere safe, then shut it down. The nice thing about it is that you can basically run as many clusters as you like in parallel, right? Which solves a lot of hassles around versioning, around like scheduling inside a cluster, because if you want, you can just create like 2 small clusters rather than 1. You can have like different clusters for different groups of people, or like different sizes depending on how much data you want to process. So you can have like, I don't know, a small cluster for your daily workload or jobs, another one for development, then like a bigger one if you want to go through like a month's worth of data, for example. All right, that's my very brief intro. Now let's talk a bit about customization. Right, so we've talked about how do you actually start a cluster, what does the life cycle look like, basically. Now the question is, how much can you influence? What can you actually do? Obviously you can write Bootstrap code, so MapReduce code, whatever other language suits a fancy. But you can also basically get into like the provisioning process and various kind of other processes that happen on this cluster to influence them. So for the remainder of the talk, I will focus on like these 2 areas. So how do we get the name node and the slave nodes, the data nodes? First of all, since they are running as EC2 instances, they're all booted from a virtual machine image, which is called an Amazon machine image, or AMI in our case. And that's basically the first choice you need to make. Which EMR image do I actually take? That influences a couple of different things. There's different generations of these AMIs available. They support different Hadoop versions and also different distros, that's another thing. And they all come with different kinds of prepackaged software. So that's like the first choice you make. Basically, so far I've talked about EMR as a service that helps you provision clusters. You can also see it as a Hadoop distro of sorts. EMR is basically Apache Hadoop, various versions plus patches. So we backport some of the patches from like later releases. We also develop our own patches and feed them back into Apache. What we also invest in is optimizing it for running on top of EC2. I'll get to that in a bit. And we invest a lot into integration with other services like DynamoDB or Kinesis or CloudWatch for like monitoring out of the box. There's a lot of different integrations also built into it. Anyway, in EMR you can currently get these Hadoop versions supported. So you can see like basically 4 generations of AMIs. That's the latest. That's the earliest that's still supported. It's quite old by now. And each AMI version can support one or more Hadoop versions. In the past, you could run like multiple Hadoop versions as part of the same AMI, but right now we're more or less moving towards a model where you have like a single Hadoop version per AMI generation. So the 2.0 AMIs will run on 1.0 something, however that line is developing, and the 3 generation, 3.0 as it is right now, will support Hadoop 2.2 and going forward basically. Another important thing is once you've decided which AMI, which Hadoop version you want to choose, if you keep restarting clusters, if you have like a lot of different clusters with different jobs, it's important to make sure that you get the right version once you ask for it. And if you launch a cluster, you basically can select the versioning schemes. You can say, I always want to run the latest, which is nice for development and testing, for example, but it's not so great for production workload. Because at some point I'll just realize that it doesn't work because software changed on weekly feed. So in this case, you can also select a major version. You can say, I want to stay on AMI 3.0, which means you will be on 2.2.0 plus patches, plus incoming security updates on the OS level, and the third-party software and so on. So the next time you'll start a cluster with this designation, you might get like 3.0.4, like a month later it could be like 3.0.5 and so on. Or if you want to be on the safe side, you can just specify the full version. And just say, this is what I've tested against, this is what my production workload should run on. And then you can basically pin this version down and make sure that all the clusters you launch use the same AMI version, which means the same software and same default configuration. Another thing you can do, we also support MapReduce version of Hadoop, so M3, M5, and 7. The nice thing about this is that all the commercial editions, like M5 and M7, you can just launch them like a regular EMR cluster. You don't have to pay for the license directly. You can basically rent the licenses over the runtime of your software. So if you want to try out EMR, that's like a safe and easy way to do it. Just start a cluster, pay a certain uplift over Apache Hadoop, give it a try, and then shut it back down. Okay, I mentioned pre-installed software that we have. This, of course, depends on the API version. What we support is like Java JDKs. Most people, I think, most people I've talked to use the Oracle one. Various versions of Ruby, Python, Perl, PHP. A lot of people use R these days. The newer AMIs come with Mahout, with Pig, Hive. And you can also use Impala if you're on the 3 series. So if you're using Hadoop 2.2 and above, you can just enable Impala in your cluster and give that a try as well, if you want to run it. The exact list of packages and the versions depend on the AMI version. That's like one of the reasons why you might want to make sure that your clusters are all on the same safe version, basically. And like the third-party packages are like one of the reasons why we might want to increase our minor version numbers in AMIs. So if there's like a big security problem in, let's say, PHP, for example, we'll probably create a new AMI version with like an updated PHP release, which you can then use without like any changes to the Hadoop setup. Okay, that much about the actual software. Talking a bit about sizing, those two should be obvious, but the two main things you need to decide on if you start a new cluster is like which size do I pick for my instances or servers. So which size should the master server have, and which size should the additional servers in the cluster have. That will obviously mean different number of CPUs, different amounts of RAM, different number and size of disks or SSDs, which has a lot of impact on the performance, of course. And secondly, you need to pick the right number of instances. Right. The nice thing about EMR is that you can actually resize the nodes in this group. So you can just keep adding new nodes to your cluster on the fly. It will automatically reconfigure, start new data nodes or new task trackers and so on, and provide you with more capacity. That's like one of the helpful things if you quickly need like more horsepower for a certain workload or job. You can do so pretty quickly. In the beginning, I've mentioned that we do a fair amount of tuning, and part of that tuning is that the EMR team runs a lot of tests on different instance sizes with different configurations, and then picks like same defaults based on the instance sizes that you've picked for your cluster and the number of instances that you've picked. So obviously, if you have like a cluster of like 1,000 small machines, the name will have more RAM, for example, and the task trackers will have like less mapper slots, for example, versus if you have a cluster with like 10 huge machines. Right? So that takes away some of the pain that you typically have to go through if you launch a new cluster, because the default should be like more or less the same. Obviously, they'll depend on the job, but at least a certain amount of tuning has been done. And another important thing is that you can override these settings, so you don't have to live with the default configurations. You can change them any way you like. You can like override individual config attributes, or you can just rip and praise the whole configuration file as part of your cluster provisioning. And the mechanism to do that is so-called Bootstrap action. But it's like one of the ways we help with automating this cluster setup. A Bootstrap action is basically a script, any kind of program that is stored in an S3 bucket. The reason being that all the nodes in the cluster will have access to that and can download it. Then the script is then downloaded and run on each of the nodes, so master and slave nodes, before Hadoop is started. So this allows you to play with the config, to, I don't know, you can even like attach Hadoop code, for example, if you like. Lots of different things you can do. And in the remainder of the talk, I'm going to talk a bit about what you can do with these things. So the first and obvious thing is, well, how do you actually start these? In the console, if my Wi-Fi works, I can show you like how you select different Bootstrap actions. On the command line, you can just pass in this argument, so put in the file name and then pass like whatever arguments you want to have. You can run up to 16 of these things per cluster launch. So it will be basically run in the order that you specify them in. Obviously, if you want to have more than 16, you can write one script which just calls the next 16 or something. There's no real limit, but on a command line, this is what you're limited to. What can you do with these things? There's like a couple of predefined Bootstrap actions that live in this S3 bucket. You can just go and have a look at them. The first one is configure daemons. It does what it says pretty much. It changes the JVM settings, essentially for a number of different daemons. So in this case, for the name node, so name node dash heap size will get translated into like a dash JMX, whatever setting on the JVM that runs the name node. There's like different aliases for the job tracker, for the resource manager, for different things that you have in your system. Then you can also pass in additional options like garbage collection settings and so on. This makes it fairly easy to just play with different configurations. So for example, if you have like one particular MapReduce job that you want to tune, you can launch like 2 different clusters in parallel with the same size and just change, like, for example, the heap size and see which of them finish the first. Fairly easy to do. The other thing is, how do you configure Hadoop itself? Also, a predefined Bootstrap action called configure Hadoop, no surprise here, that takes a number of arguments. So you can either point it to like a file on S3, another S3 bucket, which replaces your site config file, so it will just override the site config that comes with the AMI. Or, just like the second argument, which got wrapped here, -s, you can just override a certain config attribute, like on a command line, or more, if you like. Again, it's the easiest way to just influence the configuration. And the nice thing about it, if you run lots of clusters, so we've got customers that run hundreds of clusters on a single day, you can basically take that part of the configuration, and take it outside of the cluster setup itself, and just put it in the code that actually runs these clusters and monitors them. Okay, that's the easy part. That's already there for you. You can just use it, play with the config. There's a couple of ones that are helpful that are predefined as well. One of them is called run if. You can guess what it does. It basically looks at a certain amount of metadata inside your cluster. So, as I said, Bootstrap actions run on all the different nodes, the master and slave nodes. And this one will check, is the machine I'm running on my master server, so typically the name node, and if so, then run this command. Obviously this command is not very interesting, but you can, for example, modify the JVM settings for the master independently of what you do on slave nodes, or you can change the disk setup for the master, for example, or have like a different kind of backup scheme and so on. Lastly, there's no predefined action, but you can do so-called shutdown actions. They also do what they say. It's basically like one location in the file system that's there by default, and any scripts that you place there will be executed as soon as you terminate the cluster. So that's helpful for cleaning things up. Big caveat is that they need to complete within 60 seconds each. So it's like not a good idea to take like your 100 terabytes of data and try to save it somewhere else. It's probably not the right place to do it. But you can do things like monitor like downstream systems, for example, send like an email to the admin, stuff like that. All right. How do we actually write these things? As I said, they're like pretty much simple scripts. So writing them is fairly easy. You basically pick like one of the existing or pre-installed programming languages that come on your EMR of choice. I think the usual ones are all supported. Like many people use Bash, or a lot of people actually use Ruby because that's what the EMR team uses as well. So there's a lot of example code out there. They just developed the thing, but it's typically not overly complicated. You can spin up single node test clusters on which you can test to make sure that you really have the right kind of configuration. Of course, you can test locally as well. You can do log file based debugging, which is awesome, as we all know. And once you're happy with your result, you just upload it to like any S3 bucket of your choice. So it doesn't have like one of our S3 buckets. We don't have to read it. It's only important that your EMR cluster is able to read it. Right. So as I prepared this talk, I tried to launch a couple of clusters and all failed. And the reason was that it didn't have permission from my own bucket. So, well, that's not very helpful. And step 6, you're done with it. But of course, it's better if you don't actually have to write these. And the nice thing is that there's a couple of good examples that you can use to install a couple of different things. So you can use it to install HBase, for example, which as of now is already included in the later AMIs, but in previous versions you had to install it via Bootstrap action. Apache Phoenix, which is like a SQL-like, let's say, wrapper around HBase. You can use it to install Spark and Shark, which is like a lot of our customers are playing around with these days. That's kind of interesting. A lot of people install Ganglia by default. So EMR clusters are monitored by Amazon CloudWatch. You can get the data from the console and get the alerts there. But Ganglia is arguably better in terms of presenting like layered graphs of like large clusters. The latest addition that I've seen is Facebook Presto. Also like a SQL-like query engine, probably like comparable to Impala. It's also available as a Bootstrap action. And again, these make it really easy to play with some of these things. You can very easily start a cluster of like, I don't know, like a couple nodes, install Presto and give it a try. See what it actually does, how it works, then get rid of the cluster once you're done. These examples and more are all available on GitHub. I ran Apache 2 license. You just have a look and play with them. And I'd like to look at 2 examples that are a bit, to give you a better idea of what a Bootstrap action actually looks like. The first one is really easy. It's also one of the predefined ones. It's a sample called download.sh. And here it is. So this is like probably like the simplest thing you can get away with besides changing configuration file. Just run a wget on a certain bucket, download a tar file, create a directory, and then put the file's contents over there. Very simplistic, but gets the job done. If you want to distribute a lot of data, for example, before your cluster actually starts to work, you can take reference data sets, which will be downloaded from every node in parallel. You don't have to go through like any like the master nodes or like SSH, whatever. You can distribute libraries and so on. So it's like a simple example you could build on. Now, the not so simple example is the recent one that installs Facebook's Presto engine. That's also in GitHub. I'll show you the code in a second. The interesting bits in this piece of code are it integrates with a couple of the features that are in the EMR SDK that are already pre-installed. So for example, what EMR does is, if you ask it to do so, it will push all the different Hadoop log files, so task attempt logs, load logs, nodes, logs from Bootstrap actions themselves, and upload them to an S3 bucket if you're choosing like every 5 minutes or so. And one thing this Bootstrap action does is basically reconfigures this JSON file, and then make sure that the Presto log files get uploaded as well. That's an easy way to get like log shipping in place without having to do a lot of things. It also works with EMR's service nanny, which is like a set of daemon processes that run on the cluster nodes and track the health and status of the different Hadoop daemons. Basically what it does in this case is it opens this config file, or it actually takes this config file and adds it to the service nanny's directory. And then the next time it picks it up, it will start monitoring Presto in addition to things like task trackers and so on. So overall, I've got it here. So this is like a decent amount of Ruby code, so like 300 odd lines. Oops, you can actually see it. Here we go. Yeah. So this is like one of the more complex Bootstrap actions that I've seen so far. It actually figures out like if you can use apt-get or yum, depending on which kind of operating system it runs on. The operating systems are also changing from one AMI version to the next. It can parse a number of options. So for example, it can figure out like how much memory you want to reserve for Presto. That's actually one thing I don't like about this particular Bootstrap action, because it should be smart enough to actually figure this out based on the instance type and number of instances that you have and so on. I think we've done a better job here. You can set the log level. As I've said, later on the logs will be shipped on to S3. You can specify the config, and as a misnomer, you can specify the Presto version. There's a couple different versions by now. It will parse the logs. Basically, go to the very end, parse the options. We'll check the install command. We'll just install it, which in this case means it will download it. Untar it, write the actual launch code, write the config files, symlink it into the typical directory structure, install the command line client. This is the stuff that takes care of the log shipping, and then reload the service nanny. And it monitors Presto as well. Right. So this is all you need to do to get your log files shipped, for example. Basically, that's a lot of boilerplate and generates like one line of JSON code. And the actual installer itself is just download via curl, move it somewhere, change mod, then later on it will be symlinked into the path. That's the config for the service nanny. So tells it how to run it, describes the process a bit, like how to actually start and stop it. Where's the PID file, and so on. So from now on, this will be monitored by EMR as well. And I think most Bootstrap actions that I've seen don't get more complex than that. As I mentioned, one of the things I don't like about the Presto action is that it actually asks you for how much memory you want, rather than figuring out how much memory do I have, and how much should I use. So I think that's something that could be improved. Because as part of EMR, you get a lot of different metadata attributes that you can rely on to actually configure things. So for example, EMR writes a set of JSON files at this path with information about the current instance you're on, but also information about the cluster itself. So this is like one of those files. This one exists on every instance. It basically tells you, is this instance a master or not, and which of the basic daemons is it running, right? So then you can make some assumptions like how much memory you will be used in this instance typically, which processes do I need to look at, and so on. So you can make some decisions based on this. This is typically what's used with the run-if Bootstrap actions that I've shown before. Basically, run-if instance.isMaster is true, then do something which only happens on the master node. So for example, installing like the Presto command line client. Something I would probably do on the master node only, versus the rest of the system will probably be installed on the other nodes as well. That's a brief section of the job flow JSON file that has information on the cluster as a whole. So for example, it gives you like the job flow ID, which you can reference if you interact with the EMR API. It also gives you the instance count, including the master node. It gives you the ID of the master, so the EC2 instance that runs the master, and it tells you the instance types, which you could then use to actually figure out how many instances do I have, and how big are they, how many disks do they have, because that's all applied to the instance type. And it gives you the Hadoop version. If you write your own Bootstrap actions across like AMI versions or Hadoop versions, you'll probably have to look at this file quite a bit. So that's the level of metadata that EMR provides. It also gives you information about the different processing steps that you do in a separate subdirectory of this path. But of course, it doesn't end there, because you can also rely on all the other different metadata sources that we have. So for example, EC2, since we're all running in the Elastic Compute Cloud, you can always access the instance metadata service. That's a service that many people don't know about. It's available from every EC2 instance on this particular IP address. And then you can basically drill down the tree and get at the attribute that you like to have. So in this case, we're trying to figure out like which availability zone or data center is there, which might help if you're looking for, let's say, databases within the same AZ or like other servers running there. You can also figure out like which region are you running in. Like if you have a multi-region setup that is distributed globally, you can look at different virtual private cloud configuration. Which subnets are you in? You can look at the security group configuration. So what do my firewall settings look like? And once you have, for example, the ID of the security group, you can also start modifying it. Let's say if you, what's an example? So if you have a Bootstrap action that installs HBase, for example, you could probably then figure out which security group are you in, so which is basically the firewall in front of your cluster, and then open up a port for the first server, let's say, if you want to do that. That's like one example. And of course, you can use all the other AWS APIs to figure out like which DynamoDB tables do I have, like where are my databases, how many S3 buckets do I have, and so on. And all the AWS SDKs and command line tools are also installed by default, so you could just use them in your own scripts. That helps. For example, you could have a script that uses the command line client to clean up an S3 bucket. If you store temporary results there, that's something that could go into a shutdown action. All right. That's pretty much it. Already over time. So I think the general message is you can do a lot of things just by picking the right software packages to use, the right AMI to use, and then use a couple of Bootstrap actions to actually make it do what you want. So some examples are, one customer of mine didn't like the default Ganglia setup, which basically runs the Ganglia server on the master node. Instead, they wanted to have like their own Ganglia cluster, basically. So they just wrote their own Bootstrap action, right? So installing the actual collection components on the server was fairly straightforward. And then you install a component that actually pushes the data out, which Ganglia does by default. You just need to basically provide an argument that tells it like which server it should push to. You can even automate that and guess that based on, let's say, EC2 instance names and security group names and so on. Or another customer wrote a Bootstrap action that installed Uzi, or components to execute Uzi jobs. Then has another system that submits the flows into the cluster, for example. Okay. If you have any questions, now's the time, or email me at this address. And yeah, thank you.
about Puppet or Chef integration? Instead of writing Bootstrap actions, bring up a Puppet master and include that into the Bootstrap.
That in itself would be a simple Bootstrap action. That's one way to do it. Yeah, so we don't have it on the roadmap. Do you see a particular need for that? I mean, what would you like to change using Puppet or Chef? Would you want to deploy like your
Well, just have existing Puppet recipes, and rather than having to write the Bootstrap action all over again, I would just like to reuse it.
Okay.
Because I could basically test the live environment by just deploying it.
So I guess no, but I think I'll ask you, Mark, you and see if that would be of interest. I think it does make sense. So we've got a few service teams invested heavily into chefs. I guess